Next up, we are looking at volume word problems. We've looked at a bunch of problems where we talked about area of figures, so volume is a natural extension. So this particular example, we have a rectangular solid with these dimensions. What is the largest possible volume of the figure? Okay, so what we're going to do with this guy, right, we have a rectangular solid, right? So here's my awesome drawing of a rectangular solid. Bear with me here. So let's pretend that's a rectangular solid, right? So my dimensions are that this guy is x, this guy is x plus 5, and then the long way is 10 minus x. So volume of a rectangular prism, it's the area of the base times the height, right? So my volume would be x times x plus 5 times 10 minus x. Okay, so that's the formula that we are going to look at. So I'm going to go ahead and toss this into my calculator. Oops, 10 minus x, and we'll graph it and see where we end up. So this is just my normal graph here. All right, and as we can see, I really can't see everything that's going on here. It looks like I can see 3 zeros, so that's nice. But like there's a lot of height missing and a lot of depth missing. So I'm just gonna try to adjust this a little bit, make this go up and down a little bit more. So let's try going with like 100 and negative 100 and see what happens. We're talking about a volume of a figure, so that seems like it might be reasonable. All right, well, we got the bottom part, but I gotta keep going up more. So for my Y max, I'm gonna try like 200. Almost, but not quite. I'm gonna try jumping it up to 300. There we go. All right, and I think I'm gonna adjust that X just a tiny bit more. So I'm gonna make that go up to 15 just so I can see the whole thing. Perfect. All right, so here is my graph. So I'm gonna draw a little sketch of what this graph looks like. Anytime you're using a graph to solve a problem, you should always draw a sketch of it. Make sure that you label your window. There we go. Okay, so we're looking at this guy, right? And our question here is we want to find the largest possible volume. So in this particular figure, right, remember that our x is talking about the x from here. The y coordinate is my volume, right? So I'm looking for the highest possible volume. Now, because this guy goes up infinitely, that's a really hard call to make because what is going to be the biggest? There isn't one. All right, but here's the thing that we need to tweak with this guy is that we are going to have some limitations here. So we're going to have to restrict this function a little bit because of this situation that we're in. So like, first of all, I know that one of the sides is just length x, right? So one of these side lengths is just length x. And that means that that value of x can't ever be 0, right? It can't be less than 0 because then I would have a negative side length and that doesn't make sense. So the first thing that I'm going to do is I'm going to come through here and say, okay, I'm eliminating this part of the graph, right? That can't be part of my solution because then I would have negative x values. Okay. So then similarly, when I look at these other sides, x plus 5, that's not really going to restrict me at all because that's never going to be a problem. But if I look at this guy, if x is 10 or larger, then I'm going to have a problem again because once I get past 10, then this side length is going to be 0 or negative, right? So I'm going to have another kind of boundary line over here at 10, right, where this is going to be restricted off. Similarly, for my volume has to be positive. So volume can't be negative. So similarly, I'm going to restrict out the bottom part of my graph because that's where the volume is negative. So now we've kind of cut this back quite a bit until we're just looking at one particular part of this graph. All right, and that's going to help us out a bit because now we can look at this and come up with an actual answer. So where's my maximum volume? Not necessarily the maximum volume of the entire figure, but the maximum volume for the area that we're talking about. Okay, and obviously that's going to be this relative max right there. So I'm going to go back to my graph. I'm going to calculate my maximum, right? That's why it doesn't say vertex. It says maximum and minimum, right? And that looks like it's going to be the point rounded to the nearest tenth. That's 6.1 comma 264.1. Okay, so my x value is going to be 6.1. So x is going to be 6.1. which means that my dimensions are going to be 6.1 times 6.1 plus 5 would be 11.1, and then times 10 minus 6.5 would be 3.9. And there's the dimensions of my rectangular solid. Okay, so not anything too terribly difficult, pretty easy to come up with an equation. You're just going to focus on making sure you restrict to the most logical area of your graph for a solution.